Hey friends, video 8, we're almost done. We're 80% of the way there. We're into our trends for the periodic table. We're looking at trend number 2 this time for electronegativity. Your Easter egg this time around is up front. Okay, I want to show you a couple definitions and images of what electronegativity is. The definition, as you're going to go across in the notes, is how much an atom attracts electrons towards itself. In my brain, I think of it as magnetism, okay? How much this atom wants to pull electrons from other atoms to it. Now, that might not be doing it for you, so do an image search. Electronegativity trends from the bottom left corner, francium, lowest, to the top right corner, fluorine, the highest. Now, here's your Easter egg. It's two-part Easter egg. What does MoNaCo think of when he thinks of electronegativity? There's something, it's like blank. And 2, there is another term for electronegativity. It's called electron affinity. If you come to me and volunteer those 2 pieces of information, that is your Easter egg for this video. But let's get into the meat and potatoes. We're going to understand how and why the electronegativity changes as we go up or down a group and across a period. Hint, hint, it's related to electron shielding. All right. Do all the elements have the same electronegativity? No, because each element has a different number of electrons. Their electronegativities vary based on the number of valence electrons and number of energy levels and the number of protons, because it all has to do with electron shielding at the end of the day. Okay? Electronegativity is a desire to gain electrons. Okay? It's a greediness for an atom or ion for electrons, like the Grinch. Okay, the Grinch just wants them. He would have a high electronegativity. Nonmetals gain electrons to achieve the full octet of electrons. Therefore, they have high electronegativity. Nonmetals gain. They are greedy. They have an attraction for it. They pull on electrons. Metals are the opposite. They lose their electrons to get their octet, and they have a low electronegativity. Because remember, if you lose the electrons in your valence shell, it exposes the full shell that was hidden underneath it to have a full 8 electrons in it. Values of electronegativity range from 0 to 4. Table S in our reference tables has both the atomic radius, the electronegativity, all the elements' values, and if you were to graph them yourself, you would see the periodic trend. Guess what? You're going to end up doing that eventually. The most electronegative element is fluorine. That's in the top right corner of the periodic table. It is a nonmetal, and it scavenges electrons really, really well. The least electronegative element is francium. Wow, smartboard likes to be calibrated today. Francium, Fr, okay? Or cesium, Cs, because, well, francium, there just isn't enough of it around for us to really do any chemistry with. So francium or cesium are the least electronegative elements, and they are in the bottom left corner of the periodic table, which is exactly why a Google image search on such a thing would show you that type of trend. Okay? Electronegativity decreases as you go to the bottom, so there's our francium and cesium down here in the bottom left, where they're the least electronegative. They do not care. They give away their electrons easily. Up in the top corner here, francium is the most greedy. The noble gases don't play this game because they're already full of an octet of 8, and therefore they don't care about losing or gaining electrons. If you look at table S for those guys, they don't even have a number. Okay, so let's check it out here. Carrying on. Boink. So going across a period, as we know, that's from left to right, electronegativity increases. The reasons? Because of the increased nuclear charge, and the shielding does not increase. Back to that lesson on shielding. Shielding has everything to do with the trends. Here in period 3 elements, you can see that the electronegativity increases as you go from the left to the right. Now, as we go down a group, electronegativity decreases. Why? Because we have increased shielding. Remember, all these inner rings of electrons are running interference. So that valence electron does not feel the nucleus very well. And as you add another shell, it feels it less and less. So there is less of a pull for the outside electrons. Therefore, we call that decreased electronegativity. You should now be able to state how and why the electronegativity changes as we go down a group and across a period. So you can be able to add some of those pages, 15 to 22 and 27 and 28. Some of these trends are all kind of mixed together in those practice pages. So you should be able to do some more problems in those sections there. And remember, the Easter eggs. What is a synonym for electronegativity? All right. Thanks, everybody. Have a good day.